Okay, friends, we're gonna go related rates today, and it's gonna be fantastic. Okay, and for those of you who are clocking in for my in-person class, this is in fact the correct version of the problem. Okay, so again, we'll be covering related rates today. So the first thing I want from y'all is a big picture. Okay, so big picture, right? We can talk about the change in y over the change in x, right? And if we have the change in y divided by the change in x and the change in z over the change in x, right? And you know that the change in y in terms of the change in z, right? It's the same as saying the change in y over the change in x times the change in x over the change in z. It's just some dimensional analysis. Cancel out, gives you change in y over change in z. All right. So for example, you have $10 for 5 Chobani drinkable yogurts. Right. And for every 5 Chobani drinkable yogurts, you can get 3 Costco hot dogs. If you know how much a Costco hot dog costs, no, you don't. Okay, that's a great sanity check, though. All right. Then you know that, or then you can ask the question, how much is one Costco hot dog? All right. What you can do is you can say 5 Chobani drinkables is equal to $10, which means two Chobanis. Oh, sorry, not two Chobani. One Chobani is $2, right? Alternatively, you can write it in the flipped ratio. You can write it as $10 per Chobani yogurt, or 5 Chobani yogurts is the same as saying $2 per one Chobani yogurt. Right? Okay. You also know this ratio. This is saying 5 Chobani drinkable yogurts per 3 Costco hot dogs. Right? You now have this one, you now have this three, you have this Chobani drinkable yogurt on the bottom, and this Chobani drinkable yogurt on top, right? So now you know that $2 per one CDY times 5 CDY per 3 Costco hot dogs, right? That's like saying 10 is 2 times 5 is 10 per 3, which is about 150. No, that's not right. Hold up, women. Oh, let's see. Teehee. That's supposed to be 4 Costco hot dogs. Okay, so for those of you who know how much Costco hot dogs cost, shh, okay, we divide by 4 for Costco hot dog. Okay, there we go. All right. So related rates works in the exact same way. So let's do some related rates, or let's define related rates, or let's define implicit differentiation so we can do related rates. Okay, so implicit differentiation is when you derive some function in terms, or some function of some variable, which we can call A, in terms of some variable B. And it gives you derivative of A relative to derivative of B. The change in A with respect to the change of B, right? And let's note, if you are deriving in terms of A, the variable A, right? You're gonna get 1 dA dA. This is saying the rate of change of A relative to the rate of change of A. That's like asking how many minutes pass per minute. Okay? That's equal to 1. 1 times 1 is equal to 1. So you do not have to write that. Okay? So let's do some examples. Y is equal to 3x squared. Solve for dy dx. Okay, cool. Derive by x on both sides, right? Gdx of y is equal to gdx of 3x squared. And this notation is going to be called Leibniz notation. Okay. Well, this is equal to derivative of y is 1, right? And the variable we derived in terms of is, or the variable we just derived is y, right? That's why it goes on top. And you derive in terms of x. On this side, you get 6x first. If you don't know how I did this, please review the power rule times dx dx. Technically times here, which is the same as saying dy dx is equal to 6x. That's it. Similarly, once I say solve for dx dy, right? That's easy. You just say ddy of y is equal to ddy of 3x squared. Cool. This is 1 dy dy is equal to 6x to the first dx dy. Oh, wait. Oh no. You can turn this dy dy into 1, right? 6x dx dy. Oh no. There's a multiplication going on. We need to get this by itself. Just divide by 6x, right? 1 over 6x is equal to dx dy. And if you notice, these are inverses. These are reciprocals of each other. You flip them upside down. Yeah, it's pretty straightforward. Okay, so let's do an example. Okay, so let's take a look at this problem, yeah? The hardest part about these problems is figuring out what you're trying to do, what the equations are. Okay, first we want, or we know that the watermelon is a cube. Okay, right? And second, we know that the watermelon grows at this rate. This is a volume, okay? And this is volume in terms of time, volume per time, okay? I'll almost always give you like units of time as like week per week. Like if I'm saying week for one thing, use weeks for all of it, okay? So the first thing you know is dV dt is equal to 6,000 centimeters cubed per week, right? Second, you know that, I guess we should probably write in a slightly different order, huh? I guess second, we know this. And firstly, we know the watermelon is a cube, so the volume is equal to length cubed. If you don't know why this works, please review your geometry. Okay? Third, let's read that third line together. The rate of change of the length of the watermelon in terms of time. Okay, forgot to write that. In terms of time, when the surface area is 150. Okay, that's important. Surface area is equal to 150. Okay? All right. Well, that means we'll have equation number 3 as the surface area of a cube is 6L squared. If you don't know how I got that, please review your geometry. And we know that that is equal to 150. Yep. And the question is solving for length, change of the length relative to time. So you know that 4 is solve for dl dt. Okay, we can do that. We can do that, right? Okay. Where can we find dl dt? Well, we can derive this in terms of time, can we not? So let's give it a go, shall we? We know that this in terms of time is dv dt is equal to 3L squared. Let's just derive this, dl dt, because you derived length terms of time, like that, right? Okay, you know what dv dt is, right? You have this equation you're working on, you're trying to solve for this guy, right? So, big picture, right? The equation goal is dv dt is equal to 3L squared dl dt, right? We want to solve for dl dt, right? Okay, so we know that this is going to say dt is equal to 3L squared dl dt, right? Okay. Okay, yeah, we can do that, right? Then we can say, oh, we know what that volume is. We know what dv dt is. We know that dv dt is 6,000, right? And that's equal to 3L squared dl dt, right? And there's operations multiplication. Okay, what else are we missing? We're missing our L, right? Okay, that's fine. Let's solve for L, right? You know that 6L squared, I guess call this step 5, 6L squared is equal to 150, right? Which means L squared is equal to 150 over 6, right? Which is the same as 150 over 3 and 150 over 2. So I'm going to divide by 2 first. Gives me 75. 75 over 3 is 25, right? Which gives L is equal to 5. You want to use the positive value here, yeah? Okay. You know what L is. So technically, I guess you could just plug that back in, but it's okay, right? So now you know 6,000 is equal to 3 times 25, or if you'd like, you can write as 5 squared, times dl dt, right? Which is the same as saying 6,000 is equal to 75 times dl dt, right? Solve for dl dt. What's stopping it from being 1 dl dt? 75, right? So you can divide by 75 on both sides, and that should give you 80. And that is equal to dl dt. And that's it. Oh, and I guess in context, you want like 80 centimeters per week. That's it. And my solutions is written like that. Okay. All right. In a similar way, let's work out this problem. I'm going to make you guys pause for a second and work it out, and then we'll come back together. Okay? Okay. You're back here. You've already worked it out, I trust, and everything's okay. All right. Let's begin. So you have your A function, milligrams per liter, that's all, right? And you have this function, right? You have, let's do this in pink. The range is important just because it's not true for all t values, that's all. And you have to make sure everything's like overlapping properly. So you want the rate of change of A relative to the rate of change of B, right? So your goal is dA divided by dB, okay? And finally, the last detail is you know that the time is 4, okay? So let's write it out. You know A is equal to 2, 3 to the T, and then you can kind of deal with that later, right? And that means you know that dA dt, right, is equal to A to the U times ln A times du, which should give you 3 ln 2. You could just leave it like that, times 2 to the 3t. Good. You have B, which is equal to 100 times 1/2 to the power of t. That whole thing to the power of t like that. Okay? Yes, you can write it like this too. Just make sure you're not trying to go like that. It's not 1 to the t, it's the whole thing to the t. All right? I think I swapped the order out here. That's all. Well, that means you know that dB dt is equal to 100 times, because it's constant multiple, right? A to the U times ln of A times the derivative of U, which can then be written as 100 ln of 1/2 times 1/2 to the t, right? Now you have dA dt and dB dt, right? Which means you know that dA dB over dB, did I get the colors right? Yes, I did, is equal to dA times 1 over, or let me rephrase this, dA dt times 1 over dB dt. That's kind of ugly, right? So you can always rewrite that as dA dt times dt dB, right? It goes back to the whole flip it upside down thing, right? I suppose if you had been so inclined, you could have derived this whole guy in terms of B, and that gets you the TDB here, but then you'd have to scoot everything over. That kind of sucks. Okay, so great. And we want this at t equals 4. Okay? Okay, the ADT at t equals 4. This is the ADT, right? So when t equals 4 dA dt is equal to, well, you plug 4 in. This is just a function, right? Plug 4 into here. That gives you 3 ln 2 times 2 to the 4 times 3 is 12, right? I'm gonna box that in, right? Because that's relevant down here, right? Please don't say that this, don't say that this is equal to this, okay? It's specifically at t equals 4, okay? And similarly, dB dt at t equals 4 is 100 ln of 1/2 times 1/2 to the 4th, which means dt dB is just 1 divided by that whole thing. 100 times ln a half times 1/4 to the 4th. I don't care what this number is, please don't do it out. Okay? And then you just box it in and substitute. And this should give you dA over dB at t equals 4 equals, well, dA dt is this guy, right? 3 ln 2 times 2 to the 12th all over what? Whatever this pink stuff is, right? All over this. So 100, right? Because we're multiplying, that's how you got that. So you can just spot that in, right? 100 ln of a half times 1/4 to the 4th. Sorry, 1/2 to the 4th. My bad. That's it. Easy money. Okay. So what I want you to do is I want you to do worksheet 16. And I'll have solutions up whenever I get around to it. All right. Um, oh, and I guess a side note is, let's say you have a multivariable situation, right? If you have like x times y is equal to x cubed, and I want dy dx equals, right? You're gonna take ddx of both sides. You want that on the bottom, right? X times y is equal to ddx of x cubed. This is a quotient rule, right? Quotient rule, which means this splits as a and b, right? So it'll be ddx of x times y, right? A prime b plus a times b prime. So ddx of y, right? And this is going to equal 3x squared. If you don't know how this works, check your power rule, right? Oh, the derivative of x in terms of x is 1, so 1y plus the derivative of y in terms of x is x times 1 dy dx, right? This is equal to 3x squared. I guess you could write that as dx dx if you really want, right? But that just equals 1, right? You simplify this down, this gives you y plus x times 2y dx is equal to 3x squared. Now, just treat this like a variable. How do you get it by itself? Oh, move the y over. X times dy dx is equal to 3x squared minus y. Just subtract. Oh, okay. Well, you want this by itself. It's being multiplied. Divided by x. dy dx is equal to 3x squared minus y over x, because you divided by x. That's it. Thank you for your attention. I really appreciate it. I'll have solutions up in a bit. Okay, bye.